I put out a geometry one this morning. Yep.
Wait, what's the joke over there? It's a new one.
Oh, I learned from my first period class that that's how you spell log, you know? And the second one smells like up dog.
It smells like person.
You're supposed to say, what's up, dog? Okay, seriously. It's a radical function that's been shifted up dog units.
What do you call a retired coal miner? A vegan.
Doug, of course.
No, it's vegan.
Oh, I had another good one, but I can't remember off the top of my head what it was. I'll have to look that up.
Yeah, did you follow Teach Them Live? No.
This just says, what's that under there?
What's what underwear?
A
pen?
Underwear.
Oh my goodness. Okay, so your hint for what you need to replace this with, well, maybe I guess I should ask, how many choices do you have?
2. 3.
How many choices did we have for the double angle sine 2x?
1.
Didn't we only have one choice in the red there?
I believe so. You know what? Oh, that's good. Yeah.
Right? Cosine double angle had 2 or 3 different choices, but sine did not. So we should have 2 sine x cosine x. So if we go down in our notes, we should have 2 sine x cosine x. So we replaced this with that. Now, if I draw this red arrow, will that be confusing to you? Do you understand what I'm doing?
Yes.
All right, now. Don't you say cancel. But I'm glad you did point them out because they are common to both terms. So how can we factor this? What's the first rule of factoring? Always look for a greatest common factor. Yes, GCF. Right, pull it out. Okay, what are we left with? 2 sine x, is that true?
-1, yeah, -1.
2 sine x. 2 sine x. That sounds like too legit. 2 sine x. 2 sine x to quit. Okay. Now that we've got it in factored form, what do we do with each one of the factors? Yes. We took it and subtracted it to the other side. So that we got 0 on the right side. Oh, you mean right over here? Okay. We did a replacement for sine of double x there, 2x. We went back to our notes, way back up in the yonder, to the very top in the red. And we used that one and replaced. We only had one choice, so it was tough to screw it up. Okay, next. What do we do with each one of the factors? Set them equal to 0. Thank you for those who are actually paying attention. 2 sine x equals 0. So what does sine x equal? 1/2. Wait, what? Okay. Is sine an x value, a y value, a slope? It's a y value. Yeah, y sine the paper, right. Okay, so if the y value is 1/2, what are the 2 answers that you get out of that one?
That would be
Pi over 6 and 2 pi over 6. Crack me up. 5 pi over 6. Okay? So those are 2 of the answers, but there are more. We got an x value over here, don't we? The x value is 0. That happens in 2 locations on the circle. What are those? Okay, that would be pi over 2 and 3 pi over 2. So, 4 total answers. What's the confusing part? See if I can. Yes. You have to have all 4 answers. What? Ooh, now they want us to use the half-angle identities. Well, that was my fault. Yeah, no, I botched that one. Okay. Can't believe I admitted that on video, but okay. We're live. We're live. We're out to the world right now. What? Not yet. I should get a slogan, right? Teach them live. Teach them live because dead would be morbid. No? Okay. All right. No. Okay. Yeah, I know. I don't think we should do that one. It's probably a bad one. Okay, now we've got sine squared x here, and we've got 2. Now, let's see here. This is another way to write this would be sine x over 2 squared. All right. Is there anything that we could replace for this? What was it? Plus or minus. Okay. Always got to refer back to that formula sheet because nobody in the world is going to remember that stuff. No, only if I do it a bunch. And then I have to be reminded. Isn't it over 2? I think so. All right. When you square a positive number, what do you get? A positive number. When you square a negative number, what do you get? So it's not, that little plus and minus thing ain't going to really matter, is it?
Yes, why is it that?
Because it's part of the formula. It's like, Visa, can't leave home without it, kind of thing. It's right there, Okay. Now, the only reason that we have the square is the part that's getting rid of the plus and minus. Now, what happens when I take what happens when I take a square root and I square it? It cancels out. So you're telling me this is just 2 times 1 minus cosine x all over 2? Wow, that would be nice, wouldn't it? Anything else happen kind of cool on that side? One from the top, one from the bottom, that's gone. That's making my life better. Now, I got a sine squared x on the left and a cosine x on the right. That's a conundrum right there. We need to get them into the same trig. So is there anything that we could substitute for sine squared which would be useful? 1 minus cosine squared. Nice. Now we got all cosines. I think. Okay. I really think we should push everything to one side. A question? Yes.
Why would you not change it to like 1 minus cosine 2x? Like,
You mean back in the beginning?
well, like that could be for the other Well, like this one.
You're talking about for,
Like the power reducing identity.
okay. I don't, okay, let me think here. What's the best way to say this? What I'm trying to do is I'm trying to get something in a factorable form. So what I'm really looking for is a quadratic. Okay, that's why I substituted sine squared with that. Now I do understand what you're getting at. I don't think the power reducing one would help us at the moment because then we'd have a double angle. And we want everything to be single angles, you know, just like the song says, all the single angles. Okay. Well, it's either that or all the single logs, one of the two. All right, now, if I push everything over to the same side, if I push this 1 over to that side, push the cosine x over to that side, or maybe, yeah, let's just do that. What happens? Don't you say that. Won't the ones cancel out? That is true. You're subtracting a 1 from both sides, so the ones vanish, right? Because now we have, 1 minus 1, negative cosine squared x, and a positive cosine x equals 0. So as you made the y's assumption, the ones cancel out. Could we multiply this whole thing by -1 just to make it look a little nicer? What if we multiplied the whole thing by -1? That'd be like cosine squared minus cosine x, and if only we knew what 0 times -1 is. -0. That kid's gonna get kicked out of a lot of parties. -0. Okay. Is there anything that we can do to factor that? Don't you say no. Take out a cosine x, thank you. A little GCF action there. And we pull that out, we got a cosine x and a minus what? 1 equals 0. And so now we can set the factors equal to 0. We got a cosine x equals 0 and a cosine x equals 1. I know. And I know there's a couple of you going, couldn't we do this a different way? Nope, sorry. I'm pretty certain on that one. Okay. So if we think about our unit circle again, our favorite unit circle, it is. And then we start looking at cosine x equals, that's an x value. The x value is 0. We know that happens there and there. What you got? Pi over 2 and 3 pi over 2. Good job. And the cosine of x is 1. Doesn't that only happen over here? Now, be careful. Be careful. Go back to the instructions. Well, they didn't. They didn't give me... Typically, what they're going to do is they're going to give you this information. Solve for all the values from 0 to 2 pi. Okay, which they should have in those instructions. And so 0 would be a good answer. 2 pi would not be. Okay? Well, okay, if you had instructions like this, then right there is telling you you can't include 2 pi. Now, if you are asking me about all of the places in the universe, which that's true, so instead of having this restricted set of values to choose from, if you opened it up to everything in the world, all the positives and all the negatives, then you're right, 2 pi would be in that list. There'd be a whole bunch of them. Amen. Yes, we are writing 0. I will put a restriction on there when I give you the problem. I'm not sure why it isn't there, but I will definitely give you that restriction. Okay. Boy, are we ready for some homework problems together? This is what Mr. Beaujolais has been all waiting for, right? Homework time. Is that right?
Is that what
Let's see what now. Sorry for not getting the first part recorded there, but we had cosine of the first times cosine of the second minus sine of the first times sine of the second, and they've gotten me all the way to here. Cosine squared u minus sine squared u. And we are trying, look at the, remember I taught you that you need to look at the right side of the proof to get a clue as to what you need to be focused on substituting. So my guess is that you need to substitute something for this. Because the right side of my proof has only cosine squareds in it. So there's no way I want to get rid of the cosine squared. I want to get rid of the sine squared. Do you have anything that we could use? Let's think about something that might be a little bit more old time, easier Pythagorean identity-ish. 1 minus cosine squared. Taking us back. Yeah. It's like it's so familiar. And then, of course, we distribute, right? So we end up with cosine squared u minus 1 plus cosine squared u. We got 2 cosine squared u's and a minus 1. Ding, 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 ding. We did it, folks. We used our sum formula from the last section, and then we used a little Pythagorean identity to prove that. Boy, question 3 looks very similar. What do you think they did in question 3 different than what we did in question 2? They substituted that cosine squared with a 1 minus sine squared. That's what they ended up doing. So that's how they ended up with their answer on question 3. All right. So if we're doing every other, what would be the next even? 6. All right. So what do you think we should do here? Sine 2x equals sine x. Okay, I want you to work it out right now in your notes. We'll see if we agree. Okay? The whole problem, start to finish. You got 0 to 2 pi here, so make sure you add. In Algebra 2, if it said something like this, I'll try to draw it towards the bottom of the screen. 2x y minus x equals 0. Would you know how to factor something out of the left side? Okay, if you would take out an x, what would you be left with in the parentheses equal to 0? 2y minus 1. Okay, so that logic is exactly what you're going to be doing here. So we've replaced this part with 2 sine x, sorry, I forgot my 2, times cosine x. And we're pushing this to the other side, so we have a minus sine x equals 0. Now, I know I did 2 things at the same time there. I did a replacement and I subtracted. Hopefully that didn't blow brain fuses. Okay. Okay, now, I noticed that in both of these terms, there is a sine x. Okay, that is a common factor that can be pulled out. And it leaves me with 2 cosine x minus 1 equals 0. Set those puppies equal to 0. Arf, arf. Okay. Because I divided it by sine x. So if you're dividing, yeah, you still would. If you would redistribute it back in, you would get back to what I had before in the red. Okay, so did we get all our questions answered? Because people in front of me had hands raised too.
Factor, like, or not factor, but distribute the sin x to the 2 cosine x minus 1. I just want to see where
It would look exactly like this. I'm not trying to be dumb or, or make you feel bad, but okay, but you're saying if I pushed it back in, all I'm doing is multiplying. I would go right back to that green box. Okay. Now, there's no reason I would want to do that, but if I did, that's what I would get.
I was just trying to see how the sin x.
Okay. All right. Does that help?
Yeah, thank you.
Okay.
Oh my gosh, that was so confusing.
So if sine of 0
All right.
is
Good.
where
Good.
if sine of 0, does that mean it's pi over 2 or does that mean it's 0?
Well, so this is a y value, isn't it? Sine is a y value. So if I go to my circle and I'm looking for y values that are equal to 0, y values that are equal to 0, one would be there and one would be over here. So 0 and pi would be 2 of my answers.
Yeah, I don't know how you do this.
So those are just 2 of the answers from the left, from the factor on the left. Sine x equals 0, factor on the left. So obviously the other one was cosine x equals 1/2. Is cosine an x value or a y value? It's an x value, so that means my 2 answers have to be here and here. Pi over 3 and 5 pi over 3. Excellent work. Ask your question. Okay. We said that sine was a y value. So they're telling me that the y value equals 0. So I go look at the unit circle, and I literally thought to myself, where on here do we have a y value of 0? It's got to be right along the axis. And that would happen at the right side at 0 and at the left side at pi. That's all I'm doing. Number 10 is, I do want to go over or just answer this question, so bear with me. I know number 10 is not in our, or is it? It is. Oh, good. Because I was like, man, that's a good one. I like that one. All right. Here's my issue right here. Cosine 2x. Now, I know that a lot of you are going to start thinking, wait a sec, there's like 3 different things I could replace that with. What should I pick? Your hint is on the left side. What do you notice about everything on the left side? It's all about cosine. All about cosine, man. So, what do you think I should replace that red box with? Everything, something with the cosines. So go back to, in your notes, find me something we can replace that with that only has cosines involved in it. 2 cosine squared x minus 1. Excellent choice. And on the other side, I have 2 cosine squared x plus cosine x. Oh, I hope you see something beautiful about to occur. Wouldn't it make your life a little... Now, it does... If I choose the wrong one, guess what? I can still eventually get there. Okay? How, do you want to walk through the barn or around the barn? Which way do you want to go to get to the other side of the barn? I think we would want to walk through. But if you walk around the barn, you're still going to get there. It's just going to take you a little bit longer. Sometimes we do. Sometimes it do be like that. Do you see anything beautiful about to occur? Whammo, man. Wow, that was nice. I did not have to do any factoring because all I have is cosine x equals -1. And where on the unit circle do we have an x value of -1?
That's going to be at the far left side.
Which the far left side, also known on the street as pi.
Thursday.
Yes. This Thursday, yes. 3/14. Pi day. Ooh, yeah. You guys better get your money together, call in your order. I don't, you know, I think they would say probably having it in this class. You could have something after school. I'm not sure. Just don't invite any kids that say -0. Just, you know. Okay, next. 14. Man, we're just cruising through this so you can be done with your homework tonight.
We can do it like this 20 minutes afterwards to do it.
I don't care.
I like
Okay.
it.
Write the expression as one involving only sine and cosine. Okay, so sine 3 theta plus cosine 2 theta. Okay, so sine 3 theta, that would be like sine theta plus 2 theta. Theta, yes. Theta, you know, the brother of Darth. Okay, so, yeah. Yeah, I dressed up for Halloween. Last year? Yes, I wore a helmet, cape, and then I had, I printed out a shirt that, basically a sign and hung it on myself that said Darth Theta. I can pull up the picture for you. Okay. So anyway, this is a sign of a sum, right? So isn't that y, x, same sign, x, y? Okay, I took 3 theta, I used my imagination, and I said, how could I break up 3 theta? I said, hey, why don't I break it up into theta plus 2 more thetas?
Where did you get that started from?
Okay, so y of the first angle times x of the second angle plus x of the first angle times y of the second angle. And then, what do we got? Plus a 2 cosine theta. We'll finish it afterwards. That's just a little theta plus theta. That's going to be a lot easier. We'll pick this up sooner than the afterlife. So we started off this question with the sine 3 theta. And so that's sine 3 theta. We split it up into sine theta plus 2 theta. Okay, which I'm getting this sensation that you guys aren't caring at all.
Don't worry, Mr. Silly. I'm literally writing this stuff down as we speak.
Nice. Okay.
Because I need to graduate on time.
Thank you. All right, this other part, cosine 2 theta.
There we go.
At first, I thought I was going to split it into theta plus theta, but then I said, why do that? It says right here in the instructions, write the expressions as one involving only sine theta and cosine theta. So, you know, I felt like I was going to make more trouble than it was worth if I've already got an expression for cosine 2 theta. So you're going to notice that I took this cosine 2 theta and I replaced it. I took this 2 sine theta that's right here and I replaced it. And then I obviously replaced the one at the very end. I know this is not as organized a mess as I would like it to be. So if you are having difficulty following my logic, please speak now or forever hold thy peace. Okay, okay. Okay.
Why would you ever say that when I'm married?
When you what?
I'm married.
Well, He's gonna marry your cousin.
Okay, what's going on?
Oh my god. Because you know at weddings they say, blah, blah,
So you
blah,
want to marry your
speak
cousin?
out for all the things.
I'm thinking I should distribute and see if there's any like terms that can combine together just for fun. Sine theta minus sine theta squared plus 2 sine theta cosine theta. Oh man, I shouldn't have done this. Ooh, 2 sine squared cosine theta.
You have to put in the angle.
Plus, oh, of course we do. Cosine squared theta minus sine squared theta. I wonder if we have any terms that cancel out. Do you see anything that like disappears? Well, the minus sine squared thetas are both the same sign. I don't think they cancel out. I think they just add together. Okay, this one's cosine squared sine, and this one's sine squared cosine. So those don't cancel out. Man, the only thing I see is two terms that add together, those two right there. Ugly. So, I'm like, write it pretty much however you feel like writing it. There's, I don't think we should really try any tricky things here. Nah. Could I? Nah, we're not going to try any tricky things. We're just going to leave it as is. Cosine squared theta sine theta minus 2 sine squareds plus 2 sine squared cosine theta. Oops, sorry. Forgot my theta in there. Plus a cosine squared. What a mess.
Wow.
Okay, I'm not sure anything cancels out there. Now, what are you thinking might cancel out? No, can't, because that's being multiplied times cosine theta. That is ugliness. I want to see if the answer sheet has any kind of simpler version of that. Okay. For any of you who care, I found my mistakes. I can't distribute to save my life. So, there were a couple like terms in here. And let me circle them. Oops, that's not it. Come on, lock it in. Lock it in. This is a like term to this. So that gives me 3 sine theta cosine squared theta minus sine cubed theta plus cosine squared theta minus sine squared theta. Okay. Finally got that one figured out. Sorry for the mistakes, but that's it. So that's question 14. Okay, so for those of you that care about question 14, there's the corrected version. Okay, so the first part of this proof, I redid the top part of it so it looked a lot nicer, because from start to finish it should say sine 3 theta plus cosine 2 theta, and I split the 3 theta up into theta plus 2 theta. Then you can see that I took this part right here, and that's down here, and the cosine 2 theta, you can see I substituted that in the red. Oh, you can follow through the rest of this proof all the way down to the purple at the bottom. Whew, man, good question, but tough. Don't think I'd see that on a test. Okay. So what do you,
18 seconds right now.
ooh, wait a sec. What am I doing? That's not squared. That's a 2x. That's a double angle. So now I need to find a double angle formula for tangent that I can use. Is there a double angle formula for tangent? I think there's one, or is there three? Say it. What is it?
Have a good day, Mr. Staley.
2 tangent squared x.
You too. Have a
Then
good day,
what?
Mr. Staley.
Oh my goodness, I'm gonna have to write that out. Hold on. I'll have to look it up here. I can't yet. I gotta figure this one out. Okay.
Have a good day, Mr. Staley.
Hey, you do the same.
Thanks, I will.
Why was that so long?